This is a result showing the thermal forcing for the ocean, how many degrees we are above the melting point of ice, and how fast ice is melting. This is measured in meters per year. And typically for every degree in increase in ocean temperature, you melt the ice by 10 meters per year. And that's a very large number, because the surface mass balance, what's coming out on the top on the ice sheet, is only measured in centimeters per year. And what's happening when the ice meets with the ocean is measured in meters per year, or in tenths of meters per year. So you see that if you increase the ocean temperature by a few degrees, you could easily remove these ice shelves. Greenland. This view graph is, I wish we could make this a little bit darker, but this is a picture of Jakobshavn Isbrae. This is the biggest glacier in Greenland, and it discharged 10% of the ice sheet on its own. There's actually, every year, 44 gigatons of ice coming out of this glacier. I use this comparison a lot, but the LA Basin is using 1 gigaton of water per year for the whole 8 million people living in this area. We use 1 gigaton of water. This glacier alone produces enough fresh water for 44 cities like Los Angeles. It's only one glacier. It's been retreating since the Little Ice Age. It took about 50 years to retreat this much. It took 5 years to retreat this much. In the year 2000, it started collapsing. All the floating ice tongue of this glacier disappeared. And the glacier, you don't see it on this view graph, but it doubled its speed in just a few years. This is the rate of thinning, the surface lowering of the glacier with time. The glacier is coming here into the fjord. The red shows very large thinning, 15 meters per year. This is for 1997 to 2002. And if you look a few years later, the thinning is propagating inland. So the whole area is being sucked into the fjord. And the wave of thinning is propagating inland and grabbing ice from farther upstream. This glacier is flowing down a very deep trench, which is below sea level. And a lot of us think that this glacier will keep retreating from now on, because this is an unstable configuration for the glacier to be grounded below sea level and start retreating. This is the ice front of Elheim on the east coast. It was here in 2001, 2003, 2005. The scale here is about a 5-kilometer retreat in just a few years. These are the rates of thinning of the glaciers, starting from the terminal point of the glacier and going upstream. This is in kilometers. And the vertical scale is in meters. Some of these glaciers, Kangerlussuaq in East Greenland, thin 50 meters per year. With 50 meters per year, you don't need laser pointers to measure how fast they're thinning. You just go with a pot of paint, and you put a mark on the rock. Say, okay, the glacier was here in year 2000. Let's come back next year to see where it is. And you bring some ropes to find the mark on the cliff, I guess. Ice shelves in North Greenland. Even in North Greenland, we're seeing major changes. This is the Ostenfeld ice shelf in North Greenland. You see it in 2000. 2006 is gone. This is the ice shelf here in front of Zachary Istrom, which is in the northeast part of Greenland, way up there, 79 degrees north. In year 2000, this is the ice shelf. In year 2006, the ice shelf is gone. All the floating extension of the glacier is gone to sea. There's another interesting example. In West Greenland, the calving front of this glacier was over here in year 2000. In 2006, it was over here, 10 kilometers further. I know the first time I looked at this glacier, when I compared the two images, I thought, geez, I made a huge mistake. I'm looking at a different place here. So you look at it a few times to convince yourself, yeah, that whole thing is just gone. 5 kilometers, just gone to sea.